So we are graphing tangent and cotangent today. They're a little bit different than the other ones we've been doing. There's some similarities, but they are different in some ways. So I'm not going to have you guys copy this slide. This is just for discussion purposes here. Hold on a minute. You probably wouldn't have unit circle review time. So we're going to do tangent. We're going to notice the angles are different. That's one of the differences. You know, for sine and cosine, secant and cosecant, we've been using the same angles every time. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's a good set of angles to use for those because it completes one full cycle in that interval. Tangent, that's not a good set because you won't see a good cycle within that set. So what you want to do instead is use these ones. So I'm picking a different set of angles so you can see a full cycle of tangent. So here we go. Where is negative pi over 2 located on the circle?
In the bottom right quadrant.
It's at the very bottom. Now tangent, you got to think of your tangent circle. What was tangent down here? Good memory. All right. That means on the graph, that's going to be another vertical asymptote, right? All right, next one. Negative pi over 4 is here. Now, all of the tangents in the middle were what number? They were all 1. Some of them were positive and some were negative. Do you remember what this one was? It was a negative. So this one's negative 1. How about at 0? What was tangents?
0.
It was 0. How about at pi over 4? Just 1. And how about pi over 2? Undefined again. So I'm going to graph this really quick. But over here at negative pi over 2, notice it's to the left because it is a negative angle, right? We're undefined, so we have a vertical asymptote. At negative pi over 4, we're down at negative 1, like so. We'll just put that right about there. At 0, we're at 0, and then at pi over 4, we're up 1. And then finally, pi over 2, we have another vertical asymptote. That's only 3 dots. It almost looks like a straight line, but it can't be because it's got to get flat up here against that one. So how tangent looks is like this. It's from this point to this point, it's concave down. And from this point to this point, it's concave up. And then after that, you just kind of try to squish up against those asymptotes. And that's what a tangent graph looks like. Sure.
You know when you do the views?
Yeah.
How many are you gonna add? Like,
how many cycles do I want to see?
Yeah.
That's a good question. Okay. So I'm going to do the same thing here. I haven't forgot yours. I'll come back to you in a minute. But so the question is like, you know these are periodic, right? So like sine and cosine, it doesn't stop here. It just does it again, right? And so Taya's question was just, well, how many do you want to see exactly? Well, so long as you have at least one to the left and one to the right, I'm good. Because I want to know that you know that the cycle is infinitely continuing in both directions. So if you give me one on the left and right, that tells me at least you know it keeps going to some extent. Now your question was, say that again. So we had those 3 dots, right? So from here to here is concave down. That means it bends down. And then from here to here, it's concave up. And then the rest of it just goes straight up, and you want to get close to that asymptote. Okay. Those are hard to draw. I find a lot of students have it'll be interesting. Take a look at a few of your peers' papers as we draw these today. They come out looking really interesting. It's a hard one. I have a hard time drawing them, honestly, too. I don't know what it is, but there's something about that shape, getting all those dots to connect and get that shape. It's challenging. All right. So Cotangent does the same thing, and you won't be surprised to realize that it looks pretty much the same. You're going to notice something though. I've picked different angles once again. To see a full cycle of cotangent, this would be a good set of angles to start with. What do you guys predict cotangent might turn out looking like? It's just going to be going the other way. Okay, it's the reciprocal of tangent. So I think to save some time, we'll just kind of I'll let it go, but I'm not going to go and fill it out and work it out. But it ends up looking exactly the same. You're going to have undefined here, you're going to have undefined here, and then you're going to have it work out so that whenever you get your graph, instead of going up this way, it ends up going down that. That's the only difference. Okay, so let's go ahead and have you guys copy down this slide. Some things you guys are going to want to write down while you're getting these slides is the fact that this is tangent and this is cotangent. I should have had those labeled, but for some reason I did not. Another thing is you'll want to make sure you get these little measurements on here, like this is negative pi over 2, negative pi over 4, 0, and so on. So I'm going to make them a little bit bigger and darker so you can see them better. The other thing you're going to want to get is the dots that are on there. I'm talking about these dots here. There you go. So I'll wait a little while you guys copy that. Yeah.
Are we going to get marked down for not labeling the x-axis?
So for now it doesn't matter. Well, I would say starting today it might be a good idea to start labeling because now we've got different ones, right? So for sine all the way up to secant, those ones that we've been doing for the past 2 days, I kind of didn't care because they were always the same, right? But now you see we start getting some different things. So I would say from now on, yeah, definitely. And it's going to get even more different a little bit later on. So it's probably from here on out it would be good to start labeling.
Oh, I don't know.
All right, here's something for you guys to copy here. So go ahead and get that down. Okay. So when we were doing sine and cosine, this number told you our midline, right? Well, in this case, it tells you where your midpoint is at. I don't really think it's good to call it a midline. It's more like a midpoint. So, in other words, whoa, see, I screwed that up. Looks like this, right? Tangent. The midpoint's the one right in the middle there. So it tells you how far up that dot's going to go. Okay. This number here was our amplitude with sine and cosine, and it kind of does the same thing. It instead of telling you how far up to go from the midline, it just tells you how far to go up and down from the midpoint. So I'm not going to call it though the amplitude. I'm going to call it the vertical stretch because amplitude applies to waves. That's a wave word. And these aren't waves, obviously. So we're not going to call it an amplitude. We'll call it the vertical stretch here. It's not like the sine and cosine waves, right? It's like a weird. Yeah. All right. So it tells you. Remember those other two dots that we were talking about on the other slide? The A tells you how far up to get to those dots, or how far down you have to go to get to those dots. So it's the stretch factor. All right. The next slide is there's a lot to write, so stay focused and write with us. It's steps on how to graph. So guys, these are the steps that we're going to use. I'll give you a brief little overview of how they work, and then we'll actually apply them. So the first thing you got to do is you got to set up your graph, right? And now we're dealing with different angles. So you need to decide what set of angles are you using. If you're using tangent, you use one set. If you use cotangent, you use another set. It doesn't matter to me whether you use degrees or radians. these are the same thing in degrees and radians. So either way works. After that, once you get your angles set up on the graph, you're going to go ahead and put your asymptotes on there. That's step 2. Step 3, we're going to find out where the midpoint is. Now, usually the midpoint's like in the middle, right? But since if there's going to be like a plus k on there, that might shift it up a little bit. Okay. From there, we're going to decide which way is it going. Is it a tangent one, so it goes up, or is it a cotangent, so it goes down? Today, we're only going to do tangents, so the ones we're doing are going to be going up this way. And the next thing we have to do is ask how far up and down. That's what the vertical stretch factor tells us. So however big that number is, that tells you how far to go up and down from there. And then you go ahead and connect the dots, and that's pretty much it. So that's the big picture view. Let's go ahead and put it to work for us. Oh, what'd you need?
I'm literally like right there.
Go ahead. Oh, the marker's gonna. So there's one over there. I think Allison's out. Yeah.
Okay.
You're okay. Go ahead. It's fine. All right. Shall we go? See another pencil movement. I can wait a little more. I know, go on. Okay, looks like we're good. All right, write down number 1 here. You can leave the directions out because I don't care if you use degrees or radians at the moment. So just go ahead and write down the equation. So we're going to graph 2 tangent theta minus 1. I'll write it again here. So we're graphing y equals 2 tangent theta minus 1. Okay, so step 1. You guys read your steps to me. So who wants to be my reader here? All right, Allison's going to be my reader. You guys should read along with me. So what does step 1 say?
Set up your graph with theta values below.
I like it. I like it. I'm going to give you an audition for the next Siri voice.
Thank you.
All right. Now, at this point, you have to make a decision. Is it tangent or cotangent? Well, we're doing tangent, right? So which angles am I going to use, Allison?
Negative 90, negative 45, 0, 45, and 90.
Hey Siri.
Crystal clear. Crystal clear. All right. So, next step. Hey, Allison. What step? Read me step 2, please.
Sketch the asymptotes at the first and fifth theta values.
There we go. So sketch your vertical asymptotes at the first and last theta values. Okay, now the next step's a little bit confusing. I'm not going to ask Allison this time. I'm gonna say it, and then I'm gonna let her read it afterwards because the directions themselves aren't horribly clear. So the next step is to plot the midpoint. Now usually the midpoint goes right here, right? But I got a vertical shift, don't I? So I'm gonna go down 1. Okay, so I'm gonna have a dot right here. This 0 confused people in my last block, so I'll get rid of it now. But that 0 is for the angle here. So this is down 1. All right. So what did I actually write there, Allison?
Plot the k value at third theta value.
Oh, plot the k value at. Okay, good. So plot the k value at the third theta value. Okay. Now, since we're doing tangent, it's going to be going this way. So as I go over, I'm going to go up this way. And as I go to the left, I'm going to go down. Does that make sense? But the question is how far up and down. And that's what this number tells us. That's our vertical stretch. So I'm going to go over 1, up 2. And over 1, down 2. So over 1, down 2.
I thought it was up. Wait.
So to get to the next point, you always have to go over. That's always been the case, right? Even when we're doing sine and cosine is like, remember that? You always move over. So it's the same thing. To get to your next point, you have to move to the next angle. But the question is just how high up is all that matters, and this number tells you how high to go. So we went up 2 spaces because this is a 2. All right, so now we get to connect the dots. Remember, this side's going to be concave down. This side's concave up. And then try to squish it up against the asymptote as you go. And just to indicate to me that you do realize this is a periodic function, which means it repeats, I would like you to give me 1 to the left and 1 to the right. You can kind of ghetto sketch those ones. They should look roughly similar to the middle one. Ghetto sketch. Which means I'm not going to try to be very precise about where the dots are. I'm just going to make it look roughly. All right.
So I don't have to take notes in there.
I don't speak but, T. All right, there's yours. Ah. Good wait. There's no G. Write down this one really quick because Alex wants me to go back really quick. I'm going to go back for it. So write down the equation. This is your guys' student practice. Oh, I don't care if you use degrees or radians. Either way is fine for me. For now, I don't care. You good? You guys all got it written down? All right, I'm going to go back.